So we are going to see the full way of running a single proportion meta-analysis, the meta proportion package, the meta proportion package. So now our data has been imported successfully, so we can view our data here. Is it? So it's having a single event and single number of events. So we're going to use our meta proportion. So I'm going to use name our meta analysis results with my results. So meta proportion, our data. So for meta proportion, where the last video we did on meta proportion, events will come first. But let's check meta proportion. Yeah, this is it. So from our data, event is with capital letter T, then capital letter T total. Now capital letter T total, and our data, your data equals to data tab equals to, what's the name of our data here? Meta underscore meta underscore. So we have meta, you tab. So that's the name of our data. Then study lab. We have study lab here. Actually, it can be behind the data. So study lab, sorry, stud lab equals to, what is the name of the authors here? If in my data, if studies were to be here, I would put study here. But in this case, we have authors. So study lab equals to paste, paste, sorry, paste authors. Yeah, beautiful. Then we have a method. In the last video, we used inverse as a method. So let's use it. Method equals to inverse. SM, we can use p row, so that the data, there will not be any permutation in the data. Can you see? P row. So I used inverse for the method. So let's check. SM, which is the summary measure, equals to P row. So we have orders. This is a numeric which is added to event, number and sample size of the studies with 0 or all events that is studied with an event probability of either 0 or 1. We don't have that in our data. This, just read it. There are some that are not necessary. Let's check method dot confidence interval. This is a character string which method is used to calculate confidence interval for individual studies. We have so many. But the thing about this is that all these informations you still have to repeat in when while writing your code for forest plot. So most times I stop I stop at the measure summary measure. So we have other ones there. Let's check. Can you see that? Can you see that? We have other ones here. We have other ones. If you want title, you put. If you want comparison label, outcome label, subgroup, all that. But now I'm stopping here. So beautiful. This is my this is showing that the meta-analysis, the code run is successful. To visualize our forest plot, so we type forest. Let's go here. Forest. Just tap, then my result. My result is our x here, which is an object of the meta-analysis. Let's check the meaning of x. A, we can see from our help desk here. See, forest bracket x. So let's check what x stands for. X stands for an object of class meta, which means an object of meta-analysis. So, and our x here, we named it my results. So run it. See, these are plots here. Let's zoom it. So now I want to make my I want to give this I want to give this plot, I want to put a name here. This summary measure, I want to give it a name. Then I want to change this boxes to red, and I don't want to use both common and random. I just want to use random. So now I hope you're following. So now let us do some editing on our forest graph. So my results, you put comma, still check. So sort variable. This is an optional vector used to sort the individual studies. I don't need that. Then study lab, a logical indicating whether study label should be printed in the graph. Let's check our graph. Is our study label there? Because we already mentioned that when running our meta analysis here, we already put study lab is equal to paste authors. So I expect what's wrong with this thing? Okay, see, the names are there. So, but still assuming here it wasn't stated, so you can still put it here too, that stud lab, you put it. Layout, a character string specifying the layout of the forest plot. Fixed, do you want fixed, a logical indicating whether fixed or common. The fixed is also the common effect. From our graph, you know that both random and fixed were used. So now I'm going to use fixed is equal to false. Fixed is equal to false. So that's what I'm going to put here. Fixed, because I just want result for the random. Fixed equals to false. Then random equals true. So now here is overall here. So but let's check out what we've done so far. Let's check if the can you see that we only have for random effect model. The former graph was showing weight for random and weight for common, but now we have just for random. Can you see that? So now, so now after random, what else? What else? Let's check. There's so many of them. Overall, overall, a logical indicating whether overall summary should be plotted. Although I think it has been plotted on a graph, but still we can still include it. Overall, no. Overall is not there yet, so let us include overall, overall, overall equals to true. Now, after overall, we have text dot fixed. That means a character string used in the plot to label the pooled fixed events. If you want to do anything to the text, this is where you make all the settings. Then color, line color. So we are using random here. So let's use green for our random color. Color dot random tab equals to double quotes green. Green. Let's check it out. Let's check it out. Yeah. Can you see that? The green is not that deep. Let me use red. Be able to see the red very well. Red, run. So can you see? Can you see the red now? Let me change it to blue. Blue. So run. It is now blue. So let's leave it at blue. Then so I'm not doing anything with the text. So prediction. Do you want the prediction result to be there? So most times I always want my prediction to be there. Prediction tab equals true, comma. So okay, let's check if prediction is there now. Run. Let's check prediction. Can you see that? This red line, this is a prediction interval. Prediction, there's it. So there is another. Let's check. I want us to use so many. Now let's check subgroup. A single logical or logical vector indicating whether slash which subgroup result should be shown. We are not doing I'm not showing us subgroup for now, so let us keep anything with subgroup name. Another video will be dropped concerning subgroup. So Do you want the pool total and everything to be there? Let's check our graph now. So only for the total is there. Let's put for event 2. So put dot event here equals to true. So let's check. Let's check. Can you see that we now have for event 2? Interesting, right? So just try as many as possible, as many as possible. Yeah, X lab. This is the label for the X axis. The X axis for this plot. What do we want to name the X axis? The X axis, which is 0.2, 0.4, 0.6, 0.8. Let me say, let me say I am I want to label it, survivor. Survivor. So SM lab, X lab rather, X lab equals to double survivor. Survivor. Yeah, let's check. Is survivor there now? Is survivor there now? Can you see? Can you see? So, and the survivor word also I can edit it to view what position do I want the survivor to be. Then SM lab, our SM lab too is this our summary measure. What do I want to put there? What do I want to put? So let's say I am putting OR, OR, OR. So SM lab equals to double column OR. So let's check it out if it's there. Can you see that? Can you see that? So what else? Let's check. We have the X limb, the limb minimum and maximum. So do you want to put it? Reason why, if you put this one, our plot is ranges from 0.2 to 0.8. I can decide to change it to 0.1 to 1.0 to have a longer line, so but I'm not doing that for now. So weight of study, you can decide to do something with the weight. Let me use random. So weight dot study. So let's check the weight before we put it. The weight for this, we have 7.3 for the first one and 11.6 for the last one. So let's do that. Weight dot study equals to we have been using random random. So let's check. It's still the same thing. Because we have chosen random from onset. So that is why it is using random. So let me change it to fix the weight to fix. Let me change it to fix to check. Fixed. mm, is roughly same thing too, but I'll be using random. I'll be using random. Use random. Okay, so let's run it. Another thing, all studies. All studies, a logical indicating whether studies with inestimable treatment effect should be included. Assuming we have a study that the effect, treatment effect cannot be, is not estimate, we can't estimate it. If the treatment effect is inestimable, so we will put all study is equal to true. So p scale, let's use pro. We don't want any permutation in our, for our p scale. If sm is equal to any of these, so you can give numerical scaling for printing of the probabilities. So for IR scale, can you see the remaining command, the remaining instructions? So label, that's if we are for control and experimental group. Color the study, let's use that. Color of studies, color the study, color the study equals to color the study. Let's use red. Let's use red. Let's use red. Um, our graph here. So the line for the confidence interval of the study, can you see, is now red. So we can do as many as possible, as many as possible. But I want to use, can you see, color the study, the color for individual study results and confidence limit. But I want to use black for it. I'm using black. Then color the square. The square I want to use red for. Color the square. Square. Color the square. Let's use double red. Then color the color the square lines. Yeah, color dot square lines tab equals to, we've used red for that, so let me use black for the square lines. So black. So what again? Color. So the color of diamond representing the result for a fixed effect. And so let's me, the color for diamond here is gray. It's gray, so let me turn it to black. So color dot diamond, color dot diamond equals to black. You can use any color of your choice. So we have all this, they are for results. So let me see heterogeneity results. So overall we have any one of them, so you just put is log a logical value indicating So just put true, 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 true. All. If you want it to print, uh, let me use this. Print dot I to tab equals to true. Sorry, true. So let's check everything we've written so far. Can you see? Can you see that? This is all the colors that I've picked. If I want to change this to another color, I can change it. So let me change, let me put, you should put this heterogeneity, yeah, statistics equals to true, then overall tab equals to true. So let's check it out. Let's check it out. So everything I'm putting down has been there before. It has been there before. So let's check another one we can put. Yeah, label. So heterogeneity label at lab equals to true. Let's check it out. Error in must be a character vector O equals to, let me see, heter heterogeneity here. So can you see? Can you see that? So if I put capital letter H here, it changes too. So let's check. Can you see that? So what else? What else can we input? Oh, let's check if there is residual heterogeneity. So residual H start equals to true if there is any one to bring it out. So let's check. No, there is none, so we are not seeing any. With subgroup, can you see information on residual heterogeneity only added to forest plot of meta-analysis with subgroups. Can you see that this is telling us the result of the code we ran, and it's telling us an error that you can only run this if you're doing a subgroup analysis. So print I2, let's do this too. Print I2, print dot I2. Okay, I've done that one before. Tab equals to true. So print, let's use this too. Print dot t equals to true. So let's check it out. Okay, for residual, can you see so many things that is telling us? So we have the confidence interval for this now. Can you see difference in our plots now? So it depends on the information you need on your meta-analysis. So anything you know you need that you have to include, you must put it. Hive Studio will not just assume for you that yes, you have to put it, because if all this information are being included in the forest plot without us including it, will look so much ambiguous. So that is why we have to pick the ones we want ourselves. So this is it. We have so many too. The font size, the font family, it, can you see? Yeah. So the font size for the SM lab, the font size for the X lab. So let me, the X lab was the survivor we typed. So let me do fs plus X lab. Let me use 14. X lab is 14. Let's check. Let's check. Can you see? It is now larger than the other because I didn't remove the residual. That's why this information, this warning message is still repeating, because I didn't remove it. So let me put false here. So can you see? We don't have the warning message again now. So what else do we need? Font, square size. We want to change the square size. So we have so many, so many, so many. So why trying out your own? Just try as many as possible of this command. Try as many as possible. So this is the end of the meta proportion analysis with forest plots.